Hello everyone, my name is Vihasu Haspat and I'm currently studying in Sri Venkateshwara College of Engineering. Today we're going to talk about Introduction to Link State Routing, exploring the fundamentals of link state routing, its algorithms, and practical examples illustrating its real-world network applications. So first is understanding link state routing. So what are its characteristics, what are its algorithms, and what is the applications of it? The first characteristic of link state routing is that it uses a global view of the network to calculate the shortest paths from one point to another. Next is practical applications. It is used in the OSPF and the ISIS protocols for efficient data routing. What are the key algorithms used here are the Dijkstra's algorithm for finding the shortest path in a graph. So this link state routing connects one server to another in order in the smoothest or the shortest paths possible to connect and to communicate with each other. Next is what is link state routing exactly and what are its key features and protocols. So basically link state routing is a type of routing protocol used in packet switch networks. Functions of routing protocol enables routers to share link state into the accurate decisions. Next is example of this protocol includes OSPF and ISI link for state routing. Excuse me. Next is link state routing, which is explained here. First is global knowledge. Routers have a full map of the new routing decisions. Next, link state advertisements or LSAS. Routers share link states, ensuring all nodes know the network changes. Next is Dijkstra's algorithm. This is used for finding the shortest path in the link state protocols. Next is rapid convergence, quickly communicates network topology changes to all the servers. Now we compare the link state and the distance vector routing. Few of the key features are showed here. First is the knowledge of network. So link state routing has a full topology, whereas the distance network routing has only neighbors distance. Next is updated mechanisms. So LSAs to all routers is an updated mechanism in link state routing, whereas the distance vector routing has only periodic updates to neighbors. Next is the algorithm used. In link state routing, we use Dijkstra's algorithm, while distance vector routing uses Bellman-Ford algorithms. Next is convergence speed. The convergence speed of the link state routing is faster in comparison to the convergence speed of the distance vector routing, which is comparatively slower. Next, scalability. Link state routing is more scalable as you not limited to a certain distance or a neighbor, while distance vector routing is less scalable as you need neighbors to connect to further servers. Next, we're going to discuss the link state routing algorithm. So routers share link states. Routers exchange information about their connection, including cost and status. Next is builds complete network map. Each router constructs a full map of the network using shared information. Next is calculates the shortest path. Routers use Dijkstra's algorithm to find the shortest path to each node. Next is efficient routing, minimizes hops. The algorithm ensures efficient routing and reduces the number of hops in data transmission. We are going to now discuss about the Dijkstra's algorithm. So finding the shortest path in a network is what Dijkstra's algorithm does. The purpose again is to find the shortest path from a source node to all the other nodes or the destination node. The first step of this process is to initialize distances from the source node. Next is to mark the source node as visited. So every node you visited is going to be marked as visited. Next step is to update distances to the neighboring nodes. So from the source node to each and every other node present, you're going to update the distances based on the nodes you have traveled so far. Next, we're going to repeat until all the nodes, we're going to repeat the process in steps 2 and 3 till all the nodes are visited. Next, the complexity of this algorithm is V to the power 2 or O to E log V using a priority queue. Next, we're going to look at the link state routing steps. So first is to initialize. Routers initialize their link state databases. Next is link state advertisements. Routers and LSAs to all neighboring routers. Next is flooding. LSAs are flooded across the network. So instead of going from one neighbor to another neighbor, all the networks receive the data at one point. Next is building the link state database. Routers create a consistent link state database. Next is routing table calculation. Dijkstra's algorithm is used for routing table creation. Next is router network overview. So a router A connections connects to B cost 1 and C cost 4. Router B connections connects to A of cost 1, C of cost 2, and D of cost 5. Now router C connections connects to cost A with cost 4, B with cost 2, and E with cost 1. While router D connections connects to B with cost 5 and E with cost 3. Router E connections connects to C with cost 1 and D with cost 3. Next, what are the state ads and network topologies? So LSAS are packets sent by routers. They share critical link state information with other routers. Next is they contain vital data like router ID. LSAs include the router ID to identify the broadcasting router or the source. Next is include link costs and neighboring info. LSAs also detail link costs and neighboring routers for accuracy. Ensure network topology consistency. So they also help maintain updated and uniform network topology views. We're then going to see about the link state database construction. First, routers compile LSAS. Each router gathers the link state advertisements to form a network map. Next is comprehensive database. The database includes all network routers, their interconnections, and link costs. Then optimal routing calculations. The database aids in determining the most efficient routing paths. Next, we're going to see about the routing table creation steps. So initialize the distance in nodes, populate the routing table, calculate the shortest paths, and dynamic routing table updates. Few of the advantages of link state routing is efficiency, scalability, flexibility, and robustness. Few of the drawbacks are its complexity, memory usage, processing overhead, and initial overhead. Few of its uses are in enterprise networks, ISP backbone networks, data centers, and mobile networks. Link state overview is basically it's an important for crucial and efficient network management and routing. It provides a complete view and enables rapid coverage. Next is understanding LSA and digital algorithms is the fundamental for link state routing. Advantages of link state routing includes scalability and robustness. Challenges faced includes the complexity and resource usage, while the foundation for advanced networking is the foundation for advanced networking, essential knowledge for further studies in networking protocols. Thank you so much. Hope you had a great day.